Now let's talk about this worked example 3. Let's see how it goes. Very nice. It's this one, okay? ln x. And please remember this one because it doesn't look like product rule. By parts. It doesn't look like a product of two functions. But the only way that you're going to be able to integrate ln x is by using the method of by parts. Because you don't, ln x is not a derivative of anyone. We don't have it as a derivative of anyone. We know the derivative of ln x, but it is not a derivative of anyone. So how do you integrate it? You know what I mean? Because we know that the derivative, let me show you what I mean. We know that we have dy and dy dx. Where ln x, when we differentiate it, we get 1 over x, right? Which means we can integrate 1 over x. It goes to give us ln x. But if I integrate ln x, where am I going? I don't know anyone. So because of that, we have to use by parts. So you're going to say now, for integral of ln x, okay, dx. You can say integral of, maybe first, integral of ln x with respect to x is equal to the integral of 1 times ln x, okay? 1 ln x with respect to x, right? Then what would I do now? I'm going to say for integral of 1 ln x with respect to x, I would say let u be equal to, here, let's put our limit, okay? Let's put our limit. What do we have? What is 1? 1 is a polynomial. Ln is ln, which is L, the logarithmic, right? L, the logarithmic. So L comes before P, right? So he is going to be the U, and he's going to be the dv dx, basically. So you say, let U be equal to what? Ln x. Remember, it's not the order in which they are written. Okay? Good. And then dv dx now, it's lipet, okay? dv dx now. And you see, if you look at the examples in your syllabus, they'll give you examples where x is there with someone, x is there with someone, x is there with someone, a polynomial with something, right? But only in this one, in the one for ln x, right, would we have a polynomial with something, and the polynomial is not going to be the u. Because everywhere else, okay, in this and in inverse trig, of course, the last example, we'll see it again. The inverse trig is the one that will be u because it comes before the polynomial. But when we meet exponential and when we meet this trig, P is the u. Anyway, dv dx is going to be the 1. Okay. Now, that means we can get du dx, which is the derivative of this guy, of u, with respect to who? With respect to x, because it is in terms of x. What's the derivative of that? It's like the derivative of ln x. What is it? It is going to be 1 over x. Then in here, we now say the integral of dv dx. We integrate both sides with respect to x. The integral with respect to x is equal to the integral of 1 with respect to x. What do I get? The integral of this, I'll get v is equal to the integral of 1 is x, okay? It's like the integral of dx is x, right? So now what am I going to do? Now I'm going to say the integral of ln of 1 ln x, of just ln x, or 1 ln x, or we can just go to the integral of ln x dx. This is going to be equal to, or we can say 1 ln x. This is going to be equal to, let's first say integral of by parts. We have to put the by parts formula. Sorry for that. U dv dx with respect to x is going to be, we're integrating with respect to x. uv minus the integral of v times du dx, and we do it with respect to x, okay? Now, what are we going to do? What is u? We're going to take the u. What is u? U is ln x, so it's going to be ln x. It's going to multiply, okay? We're saying the integral of ln x times 1, which is here, okay? It's the one we're saying. It's the integral of ln x dx. This is going to be equal to u. What is my u? My u is ln x times v. What is my v? Times x, okay? You put x in bracket, so it's ln x by x. Minus, you can put a bracket here to show that everybody is being affected by that, minus the integral of v. What is v? It's x times du dx. What is du dx times 1 over x? So it's x times 1 over x. And I'm integrating this with respect to x. What do I now get? It is equal to ln x times x. It is x ln x minus the integral of this. What is it? It's the integral of x times 1. Because it's a whole number times it. Okay, we can say x into x1 into this is 1. So it's just going to be 1. So it's 1 with respect to x. And what are we going to get? Is the it's x ln x minus the integral of 1 is x again, okay, minus x, okay, because the integral of 1 with respect to x, so it just comes back as an x. It just comes back as an x. Then we can now put our constant of integration c at the end because we are done. And this is what you'd be having as your solution. Okay, if you want to factor out x, it's you. X, then you say ln x minus 1 plus c. That is up to you. Just playing with things. It's okay. Now you are done. We move on to the last one for the example problems, and we look at more problems, but that is it. Goodbye for now.